Hello, ladies, gentlemen, and in between, and welcome back to another episode of Maths with Hamblin with your beautiful host, Hamblin. And today, my boys, we're going to use our knowledge of graphing quadratics that we gained last video to study quadratic inequalities and how to solve them. And then I promise now we're done with quadratics and we can move on to cubics, and it'll be such a fun. Anyway, so let's finish quadratics right now. Let's go. Okay, so my boys, to start, we're going to try and solve this bad boy up here. We've got f of x equals 2x squared minus x minus 1. I'm being asked to solve f of x not equal to 0 is greater than 0. Okay, so first of all, let's think about what that means. So if we're trying to solve f of x equals 0, we're trying to figure out all the values of x such that when you chuck them into the function, it outputs positive numbers. So we're looking for a range of x values, not just two individuals, one single x value. Okay, but how could we possibly go about doing this? I mean, we know how to solve for f of x exactly equals 0, but we don't really know how to solve f of x is greater than 0. We're going to need a way to see exactly all the values of x that output positive numbers and negative numbers with a function, but how could we possibly do that? We can do it with the graph, and I'll show you what I mean by that. So what we can do is we can use our knowledge last time and graph this quadratic function. So if I graph this on an xy plane, okay, to graph a quadratic, remember, I'm not going to do the y-intercept this time because it's not very important, and you'll see why. I'm just going to do the roots. So we're going to solve 2x squared minus x minus 1 equals 0, and I'm just going to use the quadratic formula for that boy. Okay, so to find the roots, we get x equals negative b, which is 1, plus or minus the square root of, okay, b squared is 1, minus 4 times 2 times minus 1. And that's all over 4. Okay, we can do a bit of simplifying with that. That's 1 plus minus the square root of, negative times negative is positive. 1 plus 4 times 2 is 9, so that's 1 plus minus root 9, which is the same thing as 3, divided by 4. So, in other words, our first value of x is 1 plus 3 over 4, which is 1, and our second value of x is 1 minus 3 over 4, which is negative a half. Okay, and so now we can plot this on the graph. These x values are where the function outputs 0, so they're going to correspond to the points where you've got just an x coordinate and no y coordinate, because the y coordinate equals 0. So x equals 1 and x equals negative a half. Okay, so that's where it crosses the axis. And remember, this is a positive x squared coefficient, so the graph's going to look like a u, like that, okay? So we can draw it in, it's going to look something like that. Okay. And now look what's really great about this. We can visually see what values of x are outputting negative or positive numbers. For example, look here, for example, this value of x outputs a negative number. This one outputs a positive number. And in general, you can see that anything to the right of x, anything, will always output positive numbers for that function. Anything to the left of negative half will output positive. And anything just in between 1 and negative half will always output negative numbers. So we can use the graph to beautifully solve our inequality. And I'm just going to rub off that bottom bit. What? Okay, so if you want to find all the values of x where the function outputs greater than 0, all we have to say as well, all the values of x that are greater than 1, because that's where the function is getting positive numbers, or all the values of x that are less than negative a half, so further down the negative x-axis. And there we go, we've solved the quadratic inequality. And that's literally it. That's really easy, right? And so let's just get into some harder examples real quick, and then we can be done pretty much. So let's go, my boys. Okay, so my boys, this next one is just a tad more complicated. We've got that quadratic function up there, 3x squared minus 2x minus 2, and we're being asked to solve f of x is less than or equal to 0. That's what that little dash under the inequality sign means. So if we think about what the question's asking us, it's asking us to find all the values of x where you chuck it into the function and it outputs negative numbers or it outputs 0. So we need to find all the values of x such that is the case. Okay, and as we know, we can just draw the graph of the function and we can easily solve that inequality. So let's do that, shall we? I'm going to set up a plot. Okay, right, so I'm also just going to use the quadratic formula again for that one. Hope you don't mind, guys. So that's x equals 2 plus minus the square root of 4 and then minus 4 times 3 times negative 2 all over 6. Okay, let's do some simplification there, right? So negative times negative positive. 4 times 3 times 2 is 24. 4 plus 24 is 28. So unfortunately, this isn't a nice one, but that is okay. Whatever root 28 is, it doesn't matter. Oh, one of my pens just fell down. Anyway, so now we can plot the graph, pretty much. I'm not going to actually write down what the decimal value of the two values for x are, because it doesn't really matter. Because you can see that the square root of 28 is definitely going to be more than 5, right? I hope you can see why that's the case. So 2 plus root 28 over 6 is going to be positive, so it's just going to be somewhere over here. And 2 minus root 28, because root 28 is bigger than 2, when you subtract it you get a negative number, and so this will be on the negative bit as well. 2 minus root 28 over 6. And now we can draw our graph, noticing this is a positive coefficient of x squared, quadratic, so we can just draw a big U. So let's draw a U. Right, and then I'm going to rub this bottom bit out again. Okie dokie. Right, so we want to solve f of x is less than or equal to 0. So let's look at the graph and think about this. Well, we can't have any x values over here because these will output positive numbers, likewise over here. But, as you can clearly see here, I hope, all of these values in between our two roots always output negative numbers. But remember, we're also looking for f of x equals 0, so we want to include the roots. So in our answer, we want to say, okay, x is greater or equal to, because we're including the roots, 2 minus root 28 over 6, and it's less than or equal to 2 plus root 28 over 6. Now that is a pretty ugly answer, but that is the answer. So, and again, really, really easy, my boys. I hope that was alright. And let's do one more example, and then we can be done with quadratics, my boys. I'm so excited. Anyway, let's go. Okay, so my boys, I'm just going to do this last one here. It's pretty much routine. All these quadratic inequality questions pretty much just follow the same thing. They're really easy. Cubic one's a bit harder, but still easy. Oh, it's great. Anyway, right, so solving this, we're solving f of x is less than 0. Noticing we've got a negative coefficient, so this might be a little bit harder. Anyway, so let's draw the plot so we can get a visual look at all the inputs and outputs of the function. So let's draw the plot. Okie dokie. Let's find the roots. So we're going to do I'm going to use the quadratic formula again. I'm a lazy ass, you know. Right, so negative b is minus 9 plus minus the square root of 81 minus 4 times negative 1 times 10 all over minus 2. Okay, right, so that's minus 9 plus minus the square root of, okay, minus times minus, positive. 4 times 10, 4 times 10 is 40. 81 plus 40 is 121, which, if you know your square numbers, is 11 squared. So this simplifies down to the square root of 11 squared, which is 11. Divide by negative 2. We're going to get our two values for x are, first one, negative 9 plus 11, that's going to be 2, divided by negative 2 is negative 1. Our next value is going to be negative 9 minus 11 over negative 2, which, if the top of my head, is going to be positive 10. Okie dokie, let's plot our roots. So our x equals 10 here, and x equals minus 1. This is a negative coefficient x squared, so it's going to look like a big N. So let's draw that. It's going to swoop down from up here and then come back. Okie dokie, right, and let's rub the bottom bit out. Right, f of x less than 0, so we need to find all the values of x where it outputs negative numbers. So we can see the function is outputting negative numbers here and also over here. So that's numbers less than negative 1 or greater than 10. So we can say, well, x has to be less than minus 1 or x has to be greater than 10. So there we go. We've solved that quadratic inequality. There, boom. That's pretty much it, my boys. Really easy, isn't it? Like, that's just so easy. So I'm not going to do a going through examples video because You might have done that at GCSE? I don't remember. Anyway, so I hope you enjoyed that video, guys. I hope that was helpful in any way, shape, or form. Next video, look forward to the factor theorem. First bit of A-level maths. So good. Anyway, thanks for watching, guys. Smash that like button, smash that subscribe button, and I'll see you next time. Thank you.